It's day 43, which I mentioned a couple of days ago was an interesting number in and of itself, and now I get to explain why. 43 is the largest non-McNugget number. I know, right? You probably want to know what that means. So the McNugget number is actually an example of something in mathematics that's called a coin problem, where you try to figure out what the largest number is. If you take a spread of coin denominations like quarter, dime, nickel, penny, and then you try to figure out what the largest number is that you can't make with those. And there are formulae and all kinds of stuff. I'm not really up on the mathematics of it, but the McNugget number is a math problem that was thought up in the 80s by a mathematician named Henri Picciotto. And I have no idea if I'm pronouncing that right because I'm reading it straight from Wikipedia. So he was in the UK, and at the time they served McNuggets in boxes of 6, 9, and 20. And so he sat down and figured out what the largest number of McNuggets that you couldn't make with those numbers was. And it turns out it was 43. Any number higher than 43 can be made with some combination of 6, 9, and 20. So, for example, 44 is 6 plus 6 plus 6 plus 6 plus 20. 49 is 9 plus 20 plus 20. And any number larger than that can be made with some combination of those three numbers. And so 43 is the largest non-McNugget number. Now, in most places, the 9 piece has been replaced by the 10 piece, and there is a 4-piece Happy Meal size. And so in reality, there is no largest McNugget number, because if it's only 6, 10, and 20, then you can't make any odd numbers. And so you go off into infinity of odd numbers that can't be made with McNuggets. But as a fun theoretical math thing, it still amuses me. And so I was excited to share it. I was excited to share that with you. So 43, the largest non-McNugget number, if you assume those three values of McNuggets. I'll put a link to the Wikipedia article in the show notes. I will warn you that it gets very heavy into the mathematics of the whole thing, and so I could barely understand 10% of it. But if you're math inclined, it might be fun, and there are some other examples of coin problems. And you can send me an email at everyday@particulatemedia.com if you want to critique my explanation of any of those things. So that's day 43. Thanks for being here. I'll talk to you again soon.